Welcome everybody. Thanks for coming along today. My name's Tristan Smith. I work for Essex County Council, but I also am part of the Secretariat for the Essex Employment and Skills Board. It's been set up to give employers a much greater voice in terms of what's happening in skills across Essex, particularly with a focus on 7 priority sectors that we have for Essex in terms of sectors that we see there being huge opportunity for growth and jobs in the future. And one of those sectors is IT, digital and creative, which this talk will be all about and a component of that. And the reason behind us doing these talks really is to try to bring education and industry a bit closer together. So we've had quite a lot of feedback from our educators that actually sometimes the topics that are quite hot in terms of in industry aren't always things they always know everything about. Sometimes they do, sometimes they don't. So what we're trying to do is to help kind of demystify some of those topics. And so today we're very fortunate to have Steven Kear here today with us. Steven has about 15 plus years experience working in electronics and technology. And so we're very thankful for him to come along today and share some of that expertise that he has. So without further ado, over to you, Steve.
Thank you, Tristan. So I've been invited along today by the Essex Employment and Skills Board to talk about Internet of Things, artificial intelligence and big data. As I'm sure you can appreciate, these are big subjects of their own, so we could have 3 separate talks about these, but what I'm hoping to do is give you an overview as to what they are and how they're already entering lives, the opportunities that are there, and actually what's going on in the market. But first of all, I thought it might be good to just give you a small intro. So I started my sort of electronics technology career really probably at the university stage. I did computing at A level, but at that time it was very much geared towards Excel sheets and word processing, which was fine, but actually didn't really equip me for what I needed to do at university. So when I got to the university stage, it was quite a big shock in the step up that was needed even to do the basic side of things. So I did a degree in computer science, and then I went to work for a SME design consultancy called Technology Research, and this was really quite interesting because it's a team of it's varied about 10 to 12 engineers, but over the 10, 15 years we worked with some really large clients, so people like British Gas, Philips, and we also did government work. So I was one of the advisors involved with informing the government about smart technologies to use within the home. So perhaps some of you have already got the little energy monitors inside your home, so the communications go on that side. And then as Tristan mentioned, I was there for about 15 years, and I started off on the engineering side and then moved my way through the company to actually be one of the directors who looked after innovation in the company, so actually taking bits of technology and getting that to work with our customers. And then a year and a half ago I decided to strike out on by myself. So I've been involved with a couple of government initiatives, so the digital catapults, and you may have heard of these. These are all different areas where the government wants the UK to excel and exceed in. So there's one for smart cities, there's one for automotive, and there's a digital catapult. And I've worked with them as a mentor on IoT, and the digital catapult is also heavily involved with AI and things on that front. So just to throw you all, I know the title of the thing was IoT, AI and big data, but I thought from a learning point of view, I'm going to flip it on its head and start with big data, because I think that's probably the easiest way of informing you about what's going on in the world. So big data, as it suggests, isn't really what you associate with Excel. It's enormous data sets. So Excel, if you ever fancy trying it out, can hold about 1 million rows of data, but past that it will just begin to grind to a halt. And so big data is an area where we start to take data from different sources, combine them together in order to create different analytical tools and ways of working things. There will be a few people that have a moan about me bashing Excel. You can use Excel for big data and you can import stuff, but it's not the tools that we needed. So one of the questions that starts to come from all of this is, well, where are all these enormous data sets and where is all this enormous data coming from? And the simple answer to that is us. We have more and more access to tools, and people have more and more access of ways of generating data. I mean, even from today, I mean, even myself, I took a photo coming into the business school, which I'll probably tweet, and that's data that's going up onto the cloud. But to give you some idea, there's a recent article in Forbes, and Google now processes more than 40,000 searches every second. In social media, every minute there's 527,000 photos uploaded. In communication, we're sending somewhere in the range of 16 million texts. Still, people are texting, which is quite interesting. And from this side of things, you start to get an idea of where all this data is starting to build up and come from. The issue we have with it is, how is this going to be handled and how is it going to be used? And then there's also the Internet of Things side of things, which I'll come on to later, which is generating a lot of data in itself. So I also believe as well that the big data boom has had a lot to do with the reduction in the cost and the physical side of storage. So we probably all remember these, 20 years ago, this was the de facto way of storing data, your 1.44 megabytes of information. So just zoom forward 20 years, and this isn't cutting edge, this is a 32 gigabyte flash card. Well, this holds the equivalent of 22,222 floppy disks of data just on that side. So that's a clear indication to people, developers that are starting to work in this area, that actually I can store an awful lot more data for a similar cost. So this is, £8 from Amazon. That, along with all of us creating more data, has created an environment where big data and more data sets start to form, and there's actual value in those data. So are there examples of big data operating in the world today? The simple answer is yes. Unfortunately, I'm going to start on a bit of a savoury note. So we're probably all aware of the Cambridge Analytica Facebook scandal. But this gives you an idea of the kind of the big data and the vast amounts of data and what can actually be done with the data. So an alleged 50 million private Facebook profiles were harvested over the span of a couple of months. So it's not any time at all. And this was all gathered from an app, a personality app game that appeared on people's Facebook profiles, and people filled it out for a bit of fun. And one of the conditions in it was that you would share your data that you put into the app, and less well known was, in small print, it was also of all your friends and associates on that side. So this is how the data set grew. So by giving that permission, the data is being used to pass on. The data is used to understand what would need to be done to pick up people's mental and emotional vulnerabilities so that they could then be manipulated and behave in a certain way. And actually, just last week, the ICO, which is the Information Commissioner's Office, so that's the UK body that looks after data breaches and so forth, just last week gave them the maximum fine that they could, which was £500,000, which for Facebook isn't much. Had GDPR been in operation, which is the thing that's annoying us all, you have to press accept on a web page, but actually I think most people would have liked it to happen, the fine would have been $1.6 billion, so it would have been quite a different thing had this happened a few months later. And the data that was harvested for this, they've now shown was actually used to influence the 2015-2016 Donald Trump and Ted Cruz campaigns, the 2016 Brexit vote, and the 2018 Mexican general elections. And they're the ones we know about, this data and the tools and the manipulation on that side. But I'm, oddly enough, an advocate for big data, but this shows how there has to be securities and things thought about before data is just randomly used on that side. So let's go to a more positive side of things. I think most people have heard about the mapping of the Human Genome Project. So again, this is an example of using big data, and it's regarded as one of the most significant advances in the history of medical research. And by using the big data techniques now we're actually able to lower the cost of sequencing. So when they first started doing it, the projects, well, when they got to the end of the first project, was £2 billion. Now you can have your genome sequenced for £2,000, and instead of it taking a decade to sequence your genome, it can be done in a week. And this can be used for advanced medical diagnosis and advanced medical treatments on that side. Probably closer to home, Netflix uses big data, and one obvious way you'll probably be aware of is when you're going through Netflix, it will suggest other good titles, other films that you might want to see. But Netflix moved away from using data reactively, so gathering what information was, and started using it proactively. It took 6 years for Netflix to collect enough data until they were confident that they had all the ingredients they needed to make a hit show. They analysed the big data, and the show that came out of their first big data trial was House of Cards, which most people know and heard of, and was a huge success. And they've gone on and replicated this. One of the statistics is 80% of their shows have a higher hit and hit rate and audience acceptance than the remainder of all the other productions that are put out by different broadcasting companies on site. So using that model, and where we click or like a certain bit of a film, or there's a certain characters in a film that draw people towards, they've used those little bits of data to actually create programming and information that viewers like. Again, you can see that as a sinister side, but then you can also see it as a positive side. If you took that over to the educational system and lessons and lectures that are given, data from programs and talks that are given, hopefully this will be one of them, can then be selected and put together to actually produce content that's more readily available and absorbed by students and the audiences on that side. So whenever you talk to someone in big data, they mention the 3 V's, and just because it's technology, there's actually 5 of them. So, but the main things that are used to gauge big data are volume, velocity, and variety. So volume is just simply the way data's coming in. So with Excel, it's very much batch processing. So you might have students' exam results, or you might have sort of financial information. So this comes in quite slowly, and you're able to handle it quite well. But when the information starts coming in at sort of sub-real time or actual real-time level, as in data's being generated that second, that moment, that starts to be one of the factors that starts turning the data into big data. And that, again, that's purely because the amount of data that you will generate being real-time will be far greater than just simple batch side of things. Then there's the amount of data that you're collecting. So that can be from sort of traditional, more Excel side of things with megabytes level. But actually, if you go back to our Netflix example or our Facebook example, instead of megabytes of data, you've got petabytes of data. So huge quantities of data that you've got to try and trawl through and process. And then there's the variety of data, and this is a big area for big data. With Excel and databases that we're all used to, the data is normally very structured. So again, finance is all sort of decimal point level. You're dealing with percentages, or you're dealing with sort of integer values. With big data, it's far more unstructured. So you could be dealing with a tweet. So you've got a bit of text and a photo, but you still want to be able to produce. So you still want to be able to process and harvest this information. When people are looking at big data and talking about it, they normally refer to this model to analyse whether it is big data or not. There's also the value. So what value does the data have? Although I have a bit of an issue with that, because with a lot of data, you do know the value of it, but it's not until you process the data that you know its value, if you see what I mean. So I find that a little bit of an odd one to add into the big data side of things. The veracity of the data is the actual quality of the data that you're getting. So if you've got a lot of bad quality data, you're not going to end up with a particularly interesting result on that front. So I mentioned poor old Excel trying to cope with stuff, but actually what's what we're finding is traditional tools and software just weren't able to cut the mustard when it came to big data. So the real advances have come in the latest years with frameworks like Hadoop and Spark, and languages like R and Python. Now, I realise this is starting to get proper technical, but Python is, I think, the one that should ring chords with you, because Python is used on the Raspberry Pi and in hobby clubs and in schools. So it's a really important language that actually, if students or people changing careers or so forth are looking to try a programming language, something this versatile can have you running applications and demos on a Raspberry Pi, but actually working on big data projects, which is really quite exciting on that front. And the jobs really vary. So data architects, database managers, data scientists. So that's a fairly new academic study that's grown up literally in the past 10 years, but is a really highly sought after qualification. Business intelligence analysts, even down to data warehouse analysts. So, one of obviously when you're analysing this data at a high level, then that kind of commands more experience or academic input. But actually, just how you're going to store and manage the data also needs to be considered. So you're doing well. You've made it through big data, and I accept there's a lot of different concepts to cater. But I think really the thing to take away from the big data side of things is that there's a lot more data being created, and from this there's a lot of value that is obvious from the data, but there's a lot of hidden value that can be taken out. So next up, artificial intelligence. So I had a good look to try and find a definition that I could give you. There's lots out there, but at the moment, again, because it's a new subject, there's no clear agreement, which is hardly surprising when you are given the aim of what artificial intelligence is trying to meet. When you speak to most people about artificial intelligence, they think of this. Robots that are going to take control of the world and eventually decide that we don't have a relevant place for it, and have a sort of conscience, sentience, and a mind. This technically is known as strong AI or artificial general intelligence, and while there's a lot of research into that, we are a long way off of there. That doesn't mean to say that the safeguards and policies, and there's even Lords committees looking into this to making sure that rules are defined and so forth aren't valid. But actually, for this coming around the corner in the next 5 years, it's just not going to happen. But actually, many of the existing systems that are out there that scream they've got AI in aren't strong AI. They're actually known as narrow or weak AI. And what they are is they're as the name suggests, they're focused on a particular application and doing a specific defined problem. And that is very clever in itself. Obviously having the general thinking, being able to move from subject and handle different scenarios as humans are, is super complex. But actually some of the narrow AI does some very clever things too. So examples of that, well, you're probably carrying an AI example in your pocket today, which is sort of Siri, or if you're more of a Android kind of person, is Google Assistant. And equally, these AI technologies are starting to appear more in the home. So this is a Nest Thermostat, which after a couple of weeks of operation, of you setting the temperature, then starts to intelligently know how you'd like to be more comfortable. Already examples of AI are starting to appear on the market, but we didn't start there. Actually, the first AI examples came about by us providing coding rules to machines. So the thought was that actually a lot of what's in our head is just all rule-based. So if we write out lots of rules, we can, create intelligent machines. And and this is now known as classical AI. And one of the big draws at the time was chess. And so these rules were applied to chess to try and create a system that you just simply want to beat. The problem with this approach is that the possibilities and the combinations that you have to examine grow exponentially, or is called combinatorial explosion. And if I go back to the chess example, so at the start of the game, just one move generates 400 combinations of playing. By 2 moves, that's 200,000 different combinations. And then just by 4 moves, there's tens of billions of combinations that you could play with chess. So no human or even modern day computer can tackle this with any time frame that's going to be useful for playing chess. Yet we still all play chess. So how does that work? This problem fascinated Alan Turing of Bletchley Park. So after he'd finished, decrypting the Enigma and so forth, he actually turned his mind to this and proposed a set of rules to guide the computer, and these rules are kind of high-level guides that the chess program would move to. They're known as heuristics, and they're the way for the program to prune down the number of possibilities and then make a choice on that side. So, for example, one of the heuristics is to always consider capturing an undefended piece. And by adding some of these in, instead of having to code every single rule, you were able to have these certain rule points and then decide to go forward with them. In 1948, he came up with this idea and even a program to do it. It's called ChuroChamp, but obviously in 1948 there was no computer to run it on. So he did it all with pencil and paper, and it wasn't until 2001 or it might be 2010 that the actual ChuroChamp was played against Garry Kasparov, and Garry Kasparov won, but it came very close to doing that. So that kind of way of using heuristics in coding rules was very powerful, and indeed is used on a lot of things like Siri and so forth. So while it appears to be intelligence, there's a set of rules that you're going through, and that's why you eventually can come to a funny end, or it's quite easy to confuse Siri on that side. But as I mentioned, this runs into issues when you get into more complex situations. So as we know, the real world is messy and really complex. So what's really driven things forwards in the last decade or so is machine learning. So instead of us trying to give computers all the rules to handle a situation, computers learn how to make sense of the world themselves. There are lots of different aspects to machine learning and AI, but 2 areas I find really interesting are supervised learning and unsupervised learning. Google have developed an open source machine learning framework, which is an example of supervised learning. And basically what I mean by that is you're able to I suppose it's a bit like a pupil-teacher relationship, in that the area that you're trying to use the artificial intelligence on, you train it with a set of data. So in the example I'm going to give you, the TensorFlow library has been programmed with roughly about 2,000 photos, and it's for detecting various objects. And what happens is the program runs, and the user sits there and says, yes, that is a dog, no, that is a cat. And the rules actually within the machine learning form themselves so that the user is able to get a display of what's going on. So I will try and show you this. Just bear with me 1 second. I've just got to plug in some various cables. Shine it at you lot. You can see that it's actually picking out people, and by the various numbers, that's giving you an idea of how confident it thinks you're a person. And if we try shining it, we've got keyboards, we've got mice, TV. So it's not doing too bad based on the training data that it's done. And you've got to think this is quite impressive, because while this isn't the newest phone in the world, and it's able to take real-time images and then have a guess at what they are. Yes, as I said, just to recap, what was going on there is a set of predefined images had been, for example, there was probably about 300 pictures of people so male, female, the various different ages, and then so the algorithm is then got a rough idea of what it thinks, and then when it's shown to an audience in the training mode, it then asks, well, I think this is a human, is that correct? And in between it identifying and the human user saying that's correct, then it codes its own understanding of what that is and takes certain features and boundaries. And so this can be used going forward into other applications. Another area of machine learning, so this is an example of unsupervised learning. So a British AI company called DeepMind set a machine learning challenge for it to play Breakout, and basically it didn't give it any of the rules. They said all that was there was when your score gets better, what happened, and when your score gets worse, what happens, and you decide what to do. So after about 300 games and it missing, it starts to get to human level performance. So what you're seeing is quite a good human player. But what was interesting, when they got to beyond that, sort of 600 plays, it created a strategy completely of its own, which is now known as tunneling. And what you can see is it's created a tunnel here and has shot the ball behind it. And it's worked out that this has the maximum reward for the minimum risk. Now, this was something the programmers weren't expecting at all. This is completely machine thought out, but is an example where actually machine learning can benefit us on that side. So a lot of the time it's sort of shown that AI is going to be detrimental to human endeavour, but actually through examples like this, and okay, I know it's only playing the game of Breakout, it's worked out a strategy that is far more that is quite revolutionary and efficient on that side. And so if you turn that to other industries and things that were happening, what other things have we been doing the way we've been doing them for years, but just purely out of humans repeating themselves? So, and yes, as I mentioned, that whole exercise and study was developed by a British AI company called DeepMind, which has now been bought by Alphabet, which is essentially Google. I showed you some of the sort of narrow AI that's in our homes and so forth, but some of the areas where machine learning is being taken forwards are on medical imaging. So IBM Watson is working on a project with a few of the NHS foundations into looking for brain cancers and so forth. And again, at first this started off as, well, look, we can get rid of all the doctors and consultants, we'll have this computer looking through all these medical images and discovering all the things they've done. But actually the value that they found is having the machine learning sitting alongside a consultant, and not only is the consultant helping with the supervised learning and improving that side of things, but the machine learning algorithms are bringing out areas for consultants to perhaps take a look in more detail and to just up the success rate of the trials on that side. Another British company, you'll probably notice I've gone British mad in that. All you hear about AI is American. Actually, most of it's British, bought by American companies. So you've probably all heard, well, you may not have, Waymo is the Google AI driving self-driving car, but Oxbotica is an Oxford-based self-driving technology company. And where they're quite interesting, which is different from others, is they're working on the software and the tools that can be integrated into lots of different cars, rather than actually bringing out fleets of cars where you would just use a Google car or so forth like that. And again, they're using machine learning to improve the self-driving algorithms. They haven't taken the view, which I think is sensible, of the Teslas of the world, is that this has got to a point, let's put it out on the roads and see what's happening. They're actually building up the experience and the machine learning on that side. And recently, Addison Lee announced that they're going into partnership with Oxbotica to try and start offering taxi and courier services on set destinations to improve this technology. And then one that's probably far more in our lives is spam filters. And I'm not sure whether anyone's noticed recently, but if you compare, well, okay, we will still get a decent amount of spam, but perhaps it's not as bad as it was 5 years or 10 years ago. I know certainly the spam I get is far less. The reduction in spam has been, one, down to actually targeting people that are sending unsolicited emails, but two, machine learning actually being put into spam filters to make sure that you get messages through to them. And again, this goes back to the supervised learning that I was talking about earlier. So basically what a lot of the programs do now without you realizing is that when you start a new email program, a new email account from scratch, you keep the emails that are technically good emails and you delete or spam filter the others. And slowly a sample builds up of what are considered good emails and what are considered spam emails. And this is a form of supervised learning that then the program can take forwards and start to structure things. Spam filters before would look for certain words like Viagra and so forth. But if you swap the A in that for an @ symbol, it gets past the spam filter. Whereas now, with using this machine learning technology, not only are you no longer required to put in the rules for everything that is spam, the machine learning can take that forwards and adapt its own rules to make sure that the spam isn't entering into your inbox. So this is the one I constantly come across with AI, is that robots and AI will take all our jobs. So honestly, I think we have to be realistic. Jobs will disappear, but new jobs will come along too. When industrial automation came in, that replaced jobs and some very dangerous jobs at that point. But it also created new ones. And the same happened with computers. New jobs came around because of computers, and jobs now that you can only do with computers. I mean, take for example digital marketing. I mean, that just didn't exist before there was the computers and the internet on that side. And even in this sector, so I know I mentioned previously the other jobs, but there's machine learning engineers, there's again the data scientists come up, there's R&D engineers, so there's lots of new jobs that are being created, and they're not all sort of high level side of things. This can be down at the level where, you know, experience and you're actually teaching these systems is a very valuable tool. And AI is a really new area. I mean, while there's been massive leaps and developments in it, we still can't do anything like you know, a 2-year-old can. And that learning that they have, there's something that we just don't get on that side. So I think actually bringing in, and I'll come back to that, bringing in education to some of these technologies could be an interesting mix too. IoT. So we've had our data, and we know that there's lots generated and that there's value in that data. AI is actually helping people to make sense of that data and the different technologies and tools available and realizations on that side. So I looked for a definition, again, because it's a new subject, there's lots of them out there, but actually one I saw in a slide from a colleague at ARM, and ARM, if you're not aware, are the people that developed a Cambridge company that developed the chips that are practically 95% of smartphones. His definition of it was adding digital inputs and outputs to physical things. And if you want to get even less technical, it's adding communications to physical things. And a question that sort of pops into your head at first is why, but I can hopefully start to show you some of the benefits of what's happening. So one of the big things is to obviously get more information from objects that are around us. So take, for example, the humble doorbell. Its primary function was just to let you know that someone's there. But actually, IoT examples that have now started to come into the home are such as like the Nest smart doorbell. So yeah, this still lets you know that someone's there, but it also has a camera on it so you can see who's there. And using a bit of the technology that I showed you on here can start to identify who's at the door and provide two-way communications. Now, you know, it's a matter of opinion where you feel you need this in your lives, but I guess the point to take away is that it's adding value and information from objects that otherwise wouldn't generate this information. Another example of IoT in the home is Hive, which is a British gas company, and actually a project I was involved with when it was Alert Me in Cambridge. They started off with a smart thermostat, so a bit like the Nest side of things, where you can control your temperature when you're out of the home, but has grown into a whole suite of products. So we've got things like door sensors, and so you can put these on perhaps your front or back door, and it will alert you whether they're open or shut. Smart plugs, so not only can you monitor what the power something's drawing, but also remotely turn it on or off. And smart lighting and cameras, so you can see what's going on within your home. So these are all quite high level IoT examples, but it's where you would have had a traditional security system that just has a simple whether the door's been open or whether someone's moved in there but no context for them, then value's been added to those by offering different functionality and features. So is this a fad? Not fidget spinners, but IoT. By 2020, there's projected to be 200 billion smart devices out in the world, and that could equate for roughly 6.2 trillion US dollars. So it's a massive business. Those numbers are from Intel and the United Nations, and that's quite difficult to get your head around. So another way of putting it is it's roughly equivalent to the number of stars that are in the Milky Way, which is still a pretty big figure to get your head around. So think of it as 26 smart objects for every human being on Earth, which is still massive. But where are all these new sensors and applications going to come from? Because we're not all going to want smart doorbells. We're not all going to want things in the home. How are we going to get to those huge numbers? One of the major issues that we face with making things smart is it's fine when it's in a home environment or a building environment, because there's power sources and there's normally communication, so you can talk to things via Wi-Fi or such like. But actually a lot of the things we need to monitor that aren't near a power supply, so okay, the solution to that is using battery, but then trying to communicate to them is a real problem. So if you're far enough away, yes, okay, you can use the mobile phone network, but actually if you've ever come to do that in real practice, as you know from talking on your phone, it uses massive amounts of battery. So as an example, if you don't touch your smartphone all day, it's fine. You'll probably have a charge that lasts all day. But next time you use your phone, and even if you use it for about half an hour, I bet you have to charge it an hour earlier than you normally do. Or if you leave the Bluetooth on, that's because communications is really, really power hungry and drains the battery. So this is a very technical slide, but don't panic. I will try and, the idea is that I will hopefully narrow this down. So put very simply, the further up we go here is the amount of data that we can send out. So we all know from our homes that things like Wi-Fi, you can now stream videos and movies over, and that's fine. But the problem is, the further you go up here, the more power you start to consume. And as I've just mentioned, if you're going to start monitoring random objects that are no near power sources and so forth, then that's going to be no good. One of the other things you've got to consider is if we're monitoring things out in the wild and we're a long way from communications, we need these communications to travel far. And again, if I use Wi-Fi as an example, while we're doing well with getting loads of data, we're getting through our battery pretty quick. But actually, we're not broadcasting very far. We're broadcasting between 100 meters and a kilometre. So what happens if you're outside of that distance? So what's happened quite recently is, and this is probably the word that's useful, is, again, it's an acronym, it's the technology industry, is LPWAN, which stands for Low Power WAN. And the idea behind this technology is to enable communication, not very high data rate, but over long distances, that one, enables you to run things off a battery for a long while, two, enables you to communicate for quite a range, and 3 enables you to actually get data from the thing that you're trying to sense. And 2 of the most hot topic LPWAN technologies out there at the moment are Sigfox and LoRaWAN. So these have slightly different models, but basically Sigfox is being rolled out up and down the country as I suppose it's a bit like mobile phone signal technology. So it's being installed on huge masts to cover citywide areas, and you send small bits of data to it. And when I mean small, I mean sort of text message size data. No pictures, no video, nothing like that. But that has a really interesting use case, because while we do have things like smart cameras in our home and so forth, actually a lot of the stuff we need to monitor, we don't need that bandwidth at all. We just need to know what the temperature is, or whether something's present, or what light levels are. So actually having that restriction still makes it a very useful application. The thing with Sigfox is it is also a bit like the mobile phone networks, in that you sign up for a subscription. So where you'd pay sort of, I don't know if you're lucky at the moment, £5 a month for data, you'd pay £1 a year for Sigfox to send data over Sigfox network, which is good, is good. But if you're rolling things out quite large scale, that starts to become a bit of an issue. So the other technology that's happening at the moment is LoRaWAN, and this is quite different in that there's not a sort of national rollout as such. There's companies that are adding LoRaWAN signals to places, but it's actually free to use. It's still the same data rate, but the networks that are set up, there's no subscription that you need to run on that side. And one of the big initiatives behind that is someone called the Things Network. So the Things Network, it came out of Amsterdam, and the idea is that people set up their gateways, perhaps in their home, and broadcast this LoRaWAN technology for anything to use. And because it's all low data rate, it's not going to affect your broadband contract. And actually, I have a LoRaWAN gateway here. So this is it. So you'd have one of these in your home or in your business. It's got suckers on the back of it, so it sticks up to your window. And you know, with your Wi-Fi router, that it probably covers your house. So that's pretty good, perhaps 5-10 meters. So these cover 10 kilometers. And so anything within a sort of 10-kilometer range, is able to communicate, and you're able to send data back. So what's happened is, through this initiative, they've had initiators try and set up networks in different areas, and there's actually one being set up in Chelmsford, so I'm the initiator for Chelmsford, but I had a look on the map, and there's actually somebody in Colchester down in Wivenhoe that's got one in their house. So what's quite interesting is this node, which is flashing blue, is actually communicating with their house. I had no idea. It's just a nice try. I was just going to say, this is basically a sensor that's sending temperature and light information, and what that'll be doing is that'll be sending data to this person's house down in Wivenhoe, but actually then be sending it across the internet to my server, where I'm getting data information. And I suppose that kind of demonstrates the power of it, in that I'm not having to pay for this, but this enables me to create an IoT object. So this is just a sensor sending out data, but you could have this attached to sort of door sensors and start to create intelligent buildings on that side, and that's what I'll come to. So these new sensors and technologies are now starting to reach the market. So the slides I showed you previously with things like Hive and Nest, it's all very much high data rate based, all Wi-Fi solutions, so you're sending video, and there's a market and there's a need for that. But these newer type of sensors that are low power and connect invisibly are now starting to reach the market. Behringer is a very interesting case. So this is a company in Edinburgh that I work direct directly with, and so they've built a sensor that learns how people use the space within an area. It tracks air quality, temperature, and light, and collates all this information from your building to start to give you more information about what's going on. So whether, I mean, if we go back to the education setting, whether the actual room is at a good temperature, good light levels for people to learn, whether the space is being utilised properly. So maybe not so much for university, but for the NHS, that's really important, because a huge amount of their budget goes on facilities and how the building is being utilised and stuff. And if these sensors are able to tell them, well, actually, no one's used that wing, and I think probably we've all known from when we've visited hospitals or gone in there that there are vast areas that don't seem to be being used. That's a drain on the NHS budget that could be reconciled in, okay, not having all the heating conditions around that side, or actually reconfiguring things and you don't need that area of the hospital space, saving money and budget. And so they brought out this sensor that again uses the LPWAN technologies, so you don't need to connect to the building's Wi-Fi. It connects to a local network and starts to send data through, so you can build up a picture of what's going on. Another one that's been in the news lately is LeakBot. So again, this basically fits inside your home by the stopcock and cleverly measures both air and water temperatures in your home. And the theory behind it is if you have a leak in your house, the stopcock will continually draw cold water because it's leaking out. And this device then alerts you to you've got a leak. Again, okay, not that earth-shatteringly sophisticated, but it's another example of using low-power WAN technologies to communicate. So again, you put it into the home, you don't connect it to your Wi-Fi, it connects automatically, but then it starts to do some clever things as well. So if it detects a leak, it can also suggest ways to minimise the leak and call services on that side of things. But then you can also collate the data, and if you select you're happy with your data being anonymised, that can be used by the water companies to start to get an idea of leak maps and what's happening in an area. So this gives an example of a sort of IoT application where, you know, the water board know what's happening up to their pumping stations, but past that they don't have any idea of what's going on there with their networks. And so by having these sensors about, you're able to start detecting what's going on, as well as providing value to the homeowner. And this is also now recently linked up with an insurance company. So having this in your home can help reduce your insurance premium because there's an early warning system to leaks. And leaks is one of the big insurance claims because it tends to, you know, muck up your roof for a large area when it happens. For me though, I think really it's the combining it and the integration that provides us with the biggest benefits and ways of doing things. So IoT allows us to monitor in much finer detail. With the low power WAN technologies, we're able to put sensors on all different kinds of things and start to monitor them in clever ways. And I think really the wave of clever items is about to come. It's a bit like the internet. When the internet came along, it was just a lot of people's, you know, menus or, you know, basic news information. It's been a second wave of the internet where there's been some really useful apps and things created. And I think it's the same with IoT. Okay, there's equipment that you might find in your home that's useful, like being able to control your thermostat and so forth. But I think the next generation of stuff is actually going to bring some really interesting advantages. Then we have the big data that provides methods for handling all this data that IoT and everything's producing and combining that with different data sets. And then IoT can be used to make sense of it all, because as humans we just can't absorb that information. It's too much. So having methods, this can help us form different ideas. And it also aids our decision making. To give you an example, the human brain, as brilliant as it is, part of our survival thing is for us to find patterns and understanding. So we sometimes jump to conclusions, and sometimes we miss the point. So it's a bit like this optical illusion example. Is that a B or is it a 13? It all depends on your viewpoint. But actually, it being a 13 could be far more important than for it being a B. But probably the audience is split and seen different things from that side. So actually, having these technologies can help inform our decision making. And if I take an example, a very mundane example, but let's take planning, for example. So road planning. So at the moment, we put these strips across the roads, and we sort of have simple traffic counts. And really, the goal of planning is trying to efficiently move people around while effectively using the space. But are we really going to get that level of granularity by having strips just placed in the road? So this is a smart bike light, not normally associated with city planning, but it does some clever things that can allow city planning. So these will automatically flash brighter and faster at moments of risk. So when the cyclist approaches a junction or filtering traffic, the light flashes from the bike lamps increases to let people know that they're there. You can also receive alerts from it if your bike's moved when you've not been there, or it'll immediately notify an emergency contact if there's a sudden force on it. So like you unfortunately having an accident. But the interesting part is it also detects road issues and poor quality cycling conditions and traffic build-up. And this data is all gathered together onto a central map, which is then given to councils, and they're able to now build up an idea of road conditions and how traffic, bikes, bear in mind, flows through the city. So imagine if this kind of technology was extended to cars. A simple sensor that's put into cars that shares data, doesn't need to share data about where you're going, but about the road conditions and so forth. You start to have an insight from the actual objects that you're trying to plan for, rather than just having two simple road counters. And I think this pulls all the different elements together. So you've got IoT in that you've got a sensor on something that would normally be mundane, well, not mundane, but very safety important. A light would just provide light normally, but by adding a few sensors onto it, you're able to pick up road quality conditions through accelerometers and movements, air quality conditions. Then by collating this big data, you're able to put this into a central database for this to be processed and artificial intelligence worked on that side. And then the big data can then be shared with people who are actually planning stuff. That data has no real value to you, and okay, you have the option to not enroll on it on that side, but actually if you decide to share that information, then it can give far more granularity into what's needed when planning goes ahead. And as I said, this is just an example on bikes, but it really doesn't take much imagination for Ford or someone to put a small box in their car, and immediately you start to have far better planning and understanding of what's going on, and that can help traffic issues, that can help pollution issues, all by combining those technologies. So this is a bit of a call to action from you guys as in educators. So really the challenge now is to try and inspire the next generation of people into why these areas are of interest and importance. And I appreciate from my overview today that's quite difficult to necessarily get across, but some of the buzzwords and letting people know that there's opportunities and areas that can go into on that side is quite important. I think also highlighting the roles that are available in IoT, AI and big data is quite important too. And it starts at grassroots level, the getting involved with things like the microbit, the Raspberry Pi, doing some coding, Python, and the traditional subjects, science, maths and so forth, all lead into this side. And I think one of the things of the next generation is, and I suppose I've experienced it myself, is that I think roles are going to change quite drastically from you get taught your profession and that's it. I mean, I've got all my university books, but most of them are useless now because of the technology area that I'm in. So creating the ability to learn and relearn and apply new concepts is quite interesting. But as I touched on earlier in my presentation, I think it's really important that the technology industry engages with educators as well, from one, inspiring new people in, but as I mentioned, there's clearly on the AI and learning side of things something that we're drastically missing, and I've just gone through this with my daughter. I mean, my daughter's 3 years old, and between the ages of 18 months and 2 years, the amount of stuff she picked up and the amount of concepts that she got, there's something in that learning, and there's something through teaching that is obviously being missed and needs to be brought into the sort of the AI electronic side of things. That concludes where I am with the overview. I hope that's okay. There's an awful lot of information, and do feel free to ask questions. If there's other things that you suddenly think of outside, then do please drop me an email.